Hi, Math 1 students. We're going to finish up task 7.5 today. I just want a quick review of the homework you had yesterday. This was page 44. You were supposed to try the rhombus. And these are my solutions. These are posted on Canvas. But basically, hopefully you went through, you built your rhombus, put in diagonals, and then recognized all the pairs of congruent angles. Through all of the properties that we know about a rhombus and that we can visually see in this picture, we actually know that there are a lot of segments, sides, and angles that are congruent. So we had known first, all four sides are congruent. So you have those marked. And then with our diagonals bisect each other. So we have those two marks. This diagonal gets bisected. So you have those two marks that make those congruent. The diagonals are perpendicular. We have four right angles. The diagonals bisect opposite angles. I don't have that marked on here, but you could do that. And you could show with rotational symmetry and reflection also that you have those conditions. For example, if we folded this in half here, we could see that this, what I've marked as angle 3, is congruent to angle 2. Same on this side, angle 4 is congruent to angle 1. And then you could do the same thing going this direction for that fold of that line of symmetry. Angle 5 and 6 are congruent, angle 7 and 8 are congruent. So you have an awful lot of stuff there. So using all those markings in various ways, all the different triangles that are congruent, I basically had the big triangle on the left is congruent to the big triangle on the right. The big triangle on the top is congruent to the big triangle on the bottom. So that would be top, bottom triangle, and then that's the left triangle, and then the right triangle. There's a lot of different markings you can use to show that those are congruent. Make sure you understand how to write the triangle congruent statement, and the the order of the letters absolutely matters. The triangle congruence theorem that you have, and on these, since there are so many markings, there was a lot of ways to do it. And then some reasons for all of your different statements. Don't forget about shared sides are because of the reflexive property, and angles that match each other. When you have two intersecting lines, those create vertical angles, and vertical angles are congruent. So in this case, this angle would be congruent to that angle, or another pair of vertical angles is here. This angle is congruent to that angle. Both of those properties, reflexive property and vertical angles being congruent, will help you on today's quiz. The other set of triangles that are congruent are basically any of these four. Those are actually four congruent right triangles. And so any two of them could be paired at a time. And almost any triangle congruence theorem could be used to prove those congruent. And there's a lot of support for that, whether it's rotational symmetry, a reflection, or your reflexive property, or even, how about base angles of an isosceles triangle are congruent? That was the if two sides of a triangle are congruent, then two base angles are congruent. Anyway, that's some of the reasoning behind the rhombus. So now let's take a look at our final shape, which is the square. And so I'm going to just switch gears here, but keep in mind one of the important things here. A rhombus has the properties of four congruent sides. A rectangle has the property of four right angles. If you put all of that together, all of those properties together, you get the square. So here's the square. We're on page 45. I would like for you to, you can try this on your own if you would like, in a similar way that we did the last two pages. So if you want to pause the video and work on that on your own and then come back, I'm going to just review the answers here that I have on my worksheet. So a square is both a rectangle and a rhombus. It's got the four right angles and all sides are congruent. So in my picture, So draw your square, make sure all the four sides are congruent. So count off your boxes to make that happen, and draw your diagonals in here. So we have all four sides are congruent. I have that marked here. And the other properties of a square that we had before, and we can also confirm now with rotation and reflection and symmetries, we have the diagonals are congruent to each other. So you can do that with, you can show that with rotational symmetry, that the diagonals end up congruent. The diagonals bisect each other. They cut each other in half. So half of a diagonal there, if you rotate it around, it exactly matches this half of the diagonal there, and it works for both diagonals. So because the diagonals are congruent and they bisect each other, that means all four of these, let's say, half diagonals have to be congruent to each other, all four of those. The diagonals are perpendicular. If you remember, a square has 90-degree rotational symmetry. So if I turn like that, it's going to match up at 90 degrees. So every 90 degrees, this is matching up again. 360 degrees divided by 4 equal parts is 90. This is also a regular polygon because all of the angles and sides are congruent. And diagonals bisect opposite angles. So again, just like on the last one, I didn't show those. I do have all my individual angles marked. That would tell us that angle 2 and 3 are congruent, angle 4 and 5 are congruent, 6 and 7 are congruent, and 8 and 1 are congruent. In fact, if all these corners are 90 degrees, if you think about that, angle B is 90 degrees. If 2 and 3 are exactly the same angle measure, then 90 degrees divided in half is 45 degrees. So angle 2 is 45 degrees, angle 3 is 45 degrees. 4, 5, 6, 7, they're all 45 degrees. So if you think about that for a second, with the markings that we have here, I'm just going to look at this bottom one, just because of its orientation. I have two sides that are congruent to each other. So this is an isosceles triangle. Since those two sides are congruent, it means these two opposite angles are congruent, which also confirms, what we had just said, that with the bisecting information is that all these angles have to be 45 degrees. So basically what the square creates is not just four congruent triangles that were, for the rhombus, but these are four congruent isosceles triangles. They're all four exactly the same. And they all four have right angles. So these are four congruent right isosceles triangles. That's pretty specific. Anyway, so let's take a look at the triangle congruences that I picked out. And so first off, say the blue triangles. So the top left half and the bottom right half of the square. And I named that triangle ABD, congruent to triangle CBD. I could have also, because there's so much symmetry and so much alike, this could also have been named CDB. Basically, I picked the triangle, this triangle, and not the reflection of it, but the flipped. No, I did pick the reflection of that to be the congruent triangle to go with it, instead of the one that you discover by rotation. Anyway, what criteria could be used to prove these are congruent? Actually, any of our triangle congruence theorems would work, just because there are so many markings on these. We have the sides being congruent by definition of a square. We have the shared side, DB, is congruent to itself by the reflexive property. And angle A is congruent to angle C. That is also by definition of a square. All the vertices are congruent. And that would be enough to give you that one, what I just picked. That would give us we have all the sides are congruent, these two angles are congruent in that. So that would give us side, 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 matches side, side, side. Or we could do side angle side matches side angle side. So either of those directly work. You could also, put in some other markings that would also show some of these others would work too. You don't have to do all 5 reasonings, just be able to do one. The next pair of triangles with a similar set of rules is the top right triangle and the bottom left triangle that are kind of in this orange color here. And similar reasoning as the prior one. And then finally I noted all these 4 individual triangles. They're all congruent to each other, so you could basically pick any 2 pairs. The simplest way is side, 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 but actually any other would work. You would ultimately have enough markings and be able to prove that any of the triangle congruence theorems work. But the easiest one, how about just side, side, side? Or we could look at these. Side, side, side. Any of them, any 2 would work. Alright, so hopefully that makes sense. Basically, in these 3 shapes that we've done, we've shown that with rotational symmetry and reflections, or lines of symmetry, and what we know about isosceles triangles, that helps us prove all of these properties, or confirm that all these properties are true for these shapes. When we get into Module 8, we're going to work more with the properties of quadrilaterals, and hopefully you have a very solid understanding of how special these quadrilaterals are and the symmetries that help make them special and create these right triangles. Okay, so your homework for today is to do, I think it's page 47. Fill in the table with what you know to be true. Let's see if I have that to show you. So basically, it restates some properties of quadrilaterals in general. And then what you would need to do on this table is, for each of these shapes, decide whether these statements are true or false. So you put a true or false in every single box. And when you have, say, like at least one in each row, if you could state your justification why that you know that it's true, using your something about symmetry or triangles. Okay, the answer key is posted to that, but I would like for you to post your version of your answers first, and then be sure and check your accuracy. Okay, when you're done with all that, there's a mini quiz that I'd like for you to also do. So, have a great day.